Good morning, Professor Orengo, and welcome to this short interview. Thank you for finding the time. It's very nice. We were wondering, as a conference organizers, why do you think participating in events like this might be something important and relevant for sharing the work with the scientific community? What's your idea on that?
I think it's very important to attend these scientific meetings. A lot of cutting edge research that's being presented here. I've found the talks very fascinating in particular. For myself, I work in the world of globular proteins. So for people like me, it's very important to understand also these other important parts of the proteome, these non-globular proteins that, as you heard this morning, a third of the human proteome has these regions with partial disorder, and obviously they play an important role in the functional repertoire and sometimes associated with human diseases. So very important to understand that as well. And these meetings give excellent networking opportunities, and especially for young researchers to present their work in a very friendly atmosphere, and also then to discuss with each other and discuss with people who have maybe more years in the field and can advise them on directions. So I think it's a really wonderful opportunity, and I really enjoyed the format of this meeting. It's
Yeah, I think when you were saying about speaking with people that have more experience in the field, like they've been working in the field for more than 20 years, you can immediately see how they can view the different aspects at 360 degrees.
Yes.
And it's something that you don't do when you're a PhD or a first year postdoc, because it's very difficult to watch the things from far.
That's right. Yes. Yes, I think they maybe have a broader view of the field just because they've been in it for so much longer. They also have that historical perspective.
Mhm.
So they have some knowledge of things that have been tried and maybe not worked in the past, or the things that didn't work in the past because there wasn't sufficient data, but now there is, so they could be re-examined. So I think they bring that perspective that maybe young researchers can benefit from. And also I think they can help in mentoring people. They can give advice on where they might want to go for a future career, and just tips on how they might get there as well. And also they can give a lot of encouragement to younger researchers.
About having a good experience in the field, is there anything into the globular proteins world or non-globular proteins world that you feel or you think it's passing unobserved, or it should be studied more or more intensively?
Well, I think there's so much going on in both worlds, globular and non-globular. And obviously, what's important is the interaction between the two as well, but also the dynamics of both systems. And I guess that's something where we perhaps don't have sufficient data to fully model all the dynamic processes. It's an area that I'm not expert in, but it's an area that I'm becoming increasingly interested in, and also realizing that, especially I'm very interested in the evolution of enzymes, and it's sometimes it's the conformational transitions and the dynamics of these systems is very important for understanding the functional processes. So I think this is an area that will become even it's now extremely relevant now as well, but perhaps the developments will be extremely exciting over the next few years, especially if we can bring deep learning to sort of parameterization of these dynamical systems. And again, I'm not an expert, but to me, that's, with AlphaFold, we have all these sort of functional modules of proteins. We also identify the non-globular regions. And what we need now is understand how these associate and the transitions involved and conformational changes. So to me, that's going to be a very exciting next step in understanding how these systems work in the cell, which is ultimately what we need to understand.
You were mentioning AlphaFold, which is something that is becoming very known also in the non-scientific world. Why do you think this prediction tool it's important also when considering the non-scientific world?
Well, proteins are very important for all aspects of cellular life, and yet it's quite difficult to understand what a protein does just from its composition. It's just a large sort of linear macromolecule made up of all these smaller molecules, and it folds up into a specific three-dimensional shape. For globular proteins, you get these very compact shapes, and they bind things in the cell, and it's these interactions in the cell that then enable the cellular processes. And it's quite difficult to understand these without knowing the three-dimensional shape of the protein. And that's what AlphaFold has brought. After 50 years of people trying to predict the shapes from these linear composition, finally AlphaFold, using AI, deep learning, managed to find a solution, and we now have the shapes for a very large proportion of the DNA of very many organisms, including human. And once you have these shapes, for people trying to understand how we can cure diseases, it's an important step. Once you have the shape, you can understand the pockets and the surfaces that bind other things, and you can design molecules that bind into those and maybe regulate them or inhibit them in some way that is helpful for curing a disease in some way. So it's a very important step towards understanding how we can develop therapeutics for certain disease conditions.
Thank you. Before closing, I wanted to ask you again about the question, or about your final message on what you would say to the next generation of scientists, which is something I've heard already, about what you think is, or how would you approach again this scientific field? What do you think it's something that you would value in this moment if you could start again? Like if your career would start again tomorrow, let's say.
Oh, well, I think young researchers now have tremendous opportunities, actually. I mean, it's the data has expanded considerably, and the technologies for mining that data have expanded. But also, I think, we have in Europe these elixir initiatives that are very important for ensuring that the data is collected in a very consistent and normalized way, which is very important for these AI tools that they can learn properly from the data. So I think it's really it's like a transition in the field, in the sense, and we have new insights into biology from things like AlphaFold, and also applications to other areas of biology as well, imaging and so on. But we also have ways of capturing the data and mining it in a fundamentally novel and insightful way. And I think it's very important for young researchers to hold on to their understanding of the biological data. It's the most important thing, to really understand that data. And then the tools that they can use, these AI models and architectures that they can then exploit. It's very important that they're open to dialogue with the computer science communities, that they learn what might be the best architectures for them to use. But it's their understanding of the data that will really help in driving the insights and discoveries that come from these AI methods. I don't know if this is relevant, but I have a colleague who worked with Google DeepMind for 2 years, sharing his understanding of the biological data of protein structures and what forces and information had been important for predicting them. And I think that was as important as also the developments in the architecture of those technologies. So my advice is for people to stay very curious about the data, but also very open to understanding the new technologies and learning how to speak with computer scientists and appreciate those methods and not be scared of them, and use them as much as they can, but never to lose their curiosity and passion for understanding the data and the physics underpinning the sort of chemical biological concepts as well. I don't know
Thank
if
you
that
so
makes
much. It makes much sense. Thank you so much. And I hope to interview you again.
Thank you
soon.
very much for your time interview.
Thank you.
Bye.